In 1977, two spacecraft left Earth on what seemed like a relatively short scientific expedition. Their assignment was straightforward: spend a few years exploring Jupiter and Saturn, gather valuable data, and then quietly fade into history. At the time, no one expected these robotic explorers to travel beyond the known frontier of our solar system. Yet a rare alignment of the outer planets transformed an ordinary mission into one of the greatest journeys ever undertaken. That extraordinary planetary arrangement created a narrow opportunity that appears only once every 175 years. By carefully using the immense gravity of Jupiter, Saturn, Uranus, and Neptune, a spacecraft could gain tremendous speed without carrying enormous amounts of fuel. NASA recognized this once-in-a-lifetime chance and designed the Voyager mission to take full advantage of it. Although Voyager 2 lifted off first, Voyager 1 followed just 16 days later on a faster trajectory. Its greater speed allowed it to overtake its twin and become the first spacecraft to reach Jupiter and later the first to leave the solar system's planetary region. Only days after launch, Voyager 1 turned its cameras back toward home. From more than 11 million kilometers away, it photographed Earth and the Moon together in a single frame. Never before had humanity seen itself from such a distant perspective. Instead of continents and oceans, our entire civilization appeared as a tiny world suspended in the darkness of space. It was a simple image, yet it forever changed the way many people viewed our place in the universe. As Voyager 1 accelerated toward Jupiter, scientists prepared for what they believed would be a routine examination of the solar system's largest planet. Instead, the spacecraft revealed an astonishing world unlike anything astronomers had imagined. Jupiter was not a calm gas giant but an immense, restless sphere dominated by colossal storms, crushing radiation belts, and a remarkable collection of moons that behaved like a miniature planetary system. The spacecraft returned breathtaking photographs of Jupiter's atmosphere, exposing swirling cloud layers and turbulent weather systems stretching across unimaginable distances. The famous Great Red Spot, observed from Earth for centuries, was finally seen in extraordinary detail. Scientists confirmed it was an enormous storm, rotating continuously and spanning a region much larger than our own planet. Voyager also uncovered features that had escaped detection from Earth-based telescopes. A faint ring system surrounded Jupiter, proving that Saturn was not the only planet adorned with rings. Several previously unknown moons were also identified, expanding our understanding of the giant planet's complex environment. Yet the greatest surprise came from one of Jupiter's moons. Io appeared at first to be another frozen satellite, but Voyager's images told a completely different story. Towering plumes erupted hundreds of kilometers above its surface, revealing active volcanoes unlike anything ever observed beyond Earth. It became the first confirmed world outside our planet with ongoing volcanic activity, forcing scientists to rethink how small celestial bodies could generate internal heat. Europa offered an entirely different mystery. Its surface appeared unusually smooth, covered with long fractures stretching across a shell of ice. These strange patterns hinted that beneath the frozen crust might lie a vast ocean of liquid water. That possibility transformed Europa from a seemingly ordinary moon into one of the most promising places in the solar system where life could potentially exist. After completing its exploration of Jupiter, Voyager 1 continued towards Saturn, using the giant planet's gravity to gain even more speed. When it arrived in 1980, Saturn proved to be every bit as fascinating as Jupiter, revealing a level of complexity far beyond previous expectations. The spacecraft captured the planet's magnificent rings with unprecedented clarity. What had once appeared to be a few broad rings through telescopes was revealed as an intricate network of countless narrow ringlets, constantly shaped by gravity and the motion of nearby moons. Rather than being static structures, the rings formed a dynamic system that changed scientists' understanding of planetary evolution. Voyager also discovered several additional moons orbiting Saturn, each displaying unique landscapes and histories. One of the most intriguing was 1’s, whose enormous impact crater gave it an appearance unlike any other moon in the solar system. The mission's highest priority, however, was Titan. Saturn's largest moon possessed something no other moon was known to have: a dense atmosphere. Although Voyager could not see through Titan's thick orange haze, its instruments analyzed the atmosphere and uncovered a world rich in nitrogen and methane. The discovery suggested an environment where methane could exist as liquid, solid, and gas, much like water does on Earth. It was the first indication that entirely different weather systems and chemical cycles could exist far from the warmth of the Sun. Reaching Titan required an extremely close flyby, and that decision permanently changed Voyager 1's destiny. Saturn's gravity bent the spacecraft sharply out of the plane of the solar system, ending any possibility of visiting Uranus or Neptune. Its role as a planetary explorer came to an end, but a far greater mission had quietly begun. No longer bound to the worlds it had been built to investigate, Voyager 1 became humanity's first true interstellar pathfinder. Propelled by gravity, precision engineering, and a rare alignment of the planets, it began a one-way journey toward the outer boundary of the Sun's influence, a destination no human-made object had ever reached before. As Voyager 1 sped farther from the giant planets, its mission entered an entirely new phase. The spectacular flybys of Jupiter and Saturn were now behind it, but the most historic part of the journey was only beginning. Instead of chasing planets, the spacecraft was headed toward a destination no one had ever visited: the outer edge of the Sun's domain. For years, Voyager 1 drifted through the cold, dark reaches beyond the known planets, steadily approaching a mysterious boundary called the heliopause. This invisible frontier marks the point where the outward flow of charged particles from the Sun, known as the solar wind, is finally overwhelmed by the material that fills the space between stars. Scientists once believed this transition would occur gradually, with the Sun's influence slowly fading into the background. Instead, Voyager 1 encountered something far more dramatic. On August 25, 2012, its instruments recorded an abrupt transformation. The number of energetic particles streaming outward from the Sun suddenly dropped, while high-energy cosmic rays arriving from the Milky Way rapidly increased. It was as though the spacecraft had crossed an unseen border separating two entirely different environments. For the first time in history, a human-made object had entered interstellar space. This milestone was far more significant than simply setting a distance record. Voyager had crossed from a region dominated by our own star into one governed by the galaxy itself. The protective bubble surrounding the solar system, known as the heliosphere, turned out to have a surprisingly well-defined outer boundary rather than the gradual transition many researchers had expected. The discovery changed scientists' understanding of how our solar system interacts with the rest of the Milky Way. Instead of expanding freely into space, the heliosphere is constantly compressed and reshaped by pressure from the surrounding interstellar medium. Our Sun does not exist in isolation; it moves through an active galactic environment that continually influences its outer limits. Even more surprising was what Voyager detected after crossing that boundary. Many people imagine interstellar space as an endless, silent vacuum, completely empty except for scattered stars. The spacecraft revealed a very different reality. Between the stars exists an extremely thin mixture of charged particles, magnetic fields, and plasma that behaves in complex and measurable ways. One of Voyager's most remarkable observations came in the form of faint plasma oscillations. By converting these vibrations into frequencies humans could hear, scientists produced what has often been described as the sound of interstellar space. Rather than complete silence, the data revealed a continuous, high-pitched hum generated by plasma waves moving through the sparse gas between the stars. Although no one would actually hear these sounds in the vacuum of space, The recorded plasma waves allowed researchers to calculate the density of the interstellar medium with remarkable accuracy. For the first time, humanity could directly measure the material filling the vast distances between neighboring stars. Voyager also discovered that the magnetic field beyond the heliopause was considerably stronger than many theoretical models had predicted. This unexpected pressure suggested that the galaxy exerts a much greater influence on the shape of the heliosphere than scientists had previously believed.